Okay, we're on chapter 14, part 1, and in this chapter we're going to be looking at the work of wind in deserts. What you see here are some flat sand dunes in Death Valley, California. Okay, the term desertification refers to sediment, mostly sand and gravel, that are moved by the wind along the ground surface by siltation, rolling, or sliding. We'll look at the term siltation, rolling, and sliding in a minute. What we've seen is the expansion of deserts have gone into formerly productive land. Humans have played a part in that we have altered the natural vegetation patterns. And it's really important to study deserts and what caused their formation because of the large regions of the Earth's surface that are covered with deserts. About 40% of Australia is a desert. The Sahara occupies a very large portion of northern Africa. And it's also very important to understand how those desert processes operate, how they're going to affect global climate changes, and how those global climate changes are going to affect the various Earth systems. So how is sediment transported by wind? Well, we know wind is less dense than water, so only our smaller particles can be transported. Wind has a low density, so you're looking at basically only clay and your silt-sized particles. And those are going to be transported as a suspended load. The larger particles are going to be moved along the ground as bed load. Now, siltation is this process where the wind actually lifts up a sand grain, and then it drops it, it hits another grain, and that takes a little jump. Most of our sand is moved near the ground by siltation. If you've ever seen a Mexican jumping bean, the jumping bean takes a little jump, hits another bean, that one moves. Well, the same can be applied to what goes on with siltation. All those sand grains are moved by a series of little jumps that you can see, these little jumps in the picture on the bottom of the slide. Now, our suspended load are going to be our silt and our clay-sized particles. They're going to stay on the ground unless they're disturbed. Once they get picked up in the air, they can travel large distances. So this picture shows a little close-up of the different ways material or sediment can move. So in this picture right here that I've drawn an arrow under, you can see how the sand-sized grains are picked up, travel a distance, and then they fall down to the ground, hit another particle, and that particle is picked up. In the picture on the right, you can see our larger particles are transported by rolling. You can see our smaller particles are transported as suspended load, and then we also have particles transported by dissolved ions. So wind can cause some erosion, and one way the wind erodes is through abrasion. Abrasion occurs because of all these sand grains that impact an object. Kind of like sandblasting. If you've ever had a piece of metal and you brought it to get sandblasted, it comes back with all the rust off, nice and shiny. Well, the wind acts like a sandblaster. Now, wind erosion through abrasion typically only happens about a meter above the ground. So if you look at this top picture, the top picture basically has formed these strange shapes by eroding the lower part of this limestone. This is in Liberian Desert in Egypt. Ventifacts, which you can see in figure A, they're a very common product of wind erosion. So what happens with a venifact, the stones have surfaces that have been polished or grooved or pitted or faceted by the wind. So you can see in picture A, notice in number 1, you have your wind moving in this direction. So what happens by the wind just impacting that one surface, notice how in picture 2, that surface becomes abraded and it becomes angular. And then in picture 3 would be more flat surfaces are formed. So in picture B, you can see the numerous ventifacts that are shown in Death Valley. The surface where the wind attacks is going to be very polished. Another form of wind erosion would be deflation. So deflation actually removes loose sediment by the wind. Deflation hollows or blowouts could be caused from the differential erosion, which if you look at figure 14.4, you see the deflation hollow in Death Valley. Another result would be desert pavement. So desert pavement occurs when your fine material is carried off by the wind and you're just left with your pebbles and cobbles. They are actually going to form a cement to where no other particles can be eroded because all your smaller particles have been carried off by the wind. So if you notice in figure 14.5, you can see the wind is blowing toward the right. In picture A, you can see all the small particles being carried away by the wind. Your larger particles are left. And then in picture B, basically your deflation is going to end, and what you result is that desert pavement, the larger particles being cemented together. Dunes are mounds or ridges of wind-deposited sand. They are going to form when you have an obstruction that's going to stop the sand grains. Now we can have dunes without desert conditions. Dunes have an asymmetrical profile, they have a gentle windward slope, and they're going to have a steeper lee slope. They are going to migrate in the direction of the prevailing wind. So you can see here our wind is moving from left to right. Notice in this first picture down at the bottom, you can see how our sands are moving by deflation, and they're climbing up that windward side. When they get to the leeward side, they're going to cascade downward. Now, this next picture where you see the dotted lines, that is showing you how a dune migrates. So a dune is going to migrate when that sand moves up that windward side and slides down that leeward side. This is what's going to produce our cross-bedding. So cross-bedding is that type of bedding where your layers are deposited at an angle to where they accumulate. Typically, it's found in sand dunes. So you can see all the cross-bedding that's shown in this picture. You have a series of angular beds. This is in Zion National Park in Utah. So by looking at this cross-bed, we're able to determine the direction of the prevailing wind. Now, we do have different types of dunes. We're going to talk about these 4 different types, and the types are determined by your sand supply, the direction and the velocity of the wind, and your amount of vegetation. So let's look at the Barkan first. So Barkan dunes have the crescent shape that you can see at the picture on the bottom. The tips, which these that I'm circling right here, always point downwind. So as you can see in this figure, your wind's blowing from bottom to top. You're going to find Barkan dunes on flat, dry surfaces that have little vegetation and a nearly constant wind direction. Barkan dunes are the most mobile of the major dune types. They can move 10 plus meters per year. They can also be up to about 30 meters high. You can see in this picture on the right a ground level view of several barchan dunes. Another type is our longitudinal dunes. So these are those long parallel ridges of sand that are parallel to the prevailing wind direction. So you can see our wind direction on this bottom picture, and notice your dune is parallel to that wind direction. So you're going to find these longitudinal dunes in more areas where you have a limited sand supply. So your winds typically will converge from slightly different directions. They can be 3 up to 100 meters in height, up to about 100 kilometers long. We see a lot of our longitudinal dunes in Australia, Saudi Arabia, Egypt, and Iran. Our transverse dunes are going to be perpendicular to the prevailing wind direction. They're going to be long ridges, just like our longitudinal dunes, but perpendicular to the wind direction. In order for a transverse dune to form, you have to have abundant sand with little or no vegetation. Sometimes transverse dunes are actually called sand seas. Notice they can be pretty high, up to about 200 meters, and they can be up to 3 kilometers wide. So here's our wind direction. Our dunes are perpendicular to that wind direction. This picture was blown up from the Great Sand Dunes National Monument in Colorado. We could also have what we call parabolic dunes. A parabolic dune is typically going to form in coastal areas with abundant sand and strong offshore winds. So what happens is your vegetation cover is broken from a deflation, hollow, or a blowout. Now, a parabolic dunes will have that crescent shape, but their tips are going to point upwind. Here's our wind direction right here. And you can see this was taken from this bigger picture, which was taken on the shores of Lake Michigan. Okay, this ends part 1 of chapter 14.